so we're going to get started with an NX Monorepo, which is another construct offered by the PDK, which is a great base for any project. So we're in an empty directory and we're going to run npx progen new from AWS prototyping SDK NX Monorepo. And what this will do is we'll bootstrap us with a bunch of project files, specifically a progen RC, which is then used to add more projects defined as progen constructs, which lets us add in different building blocks from the PDK. So I'll let that run and check back in a moment. Okay, so it looks like that's finished, and we'll just let IntelliJ catch up, and hopefully we'll see all of our project files. All right, so the progen RC is the best place to start. So this is a bit like CDK, where we have constructs that instead of defining resources in CloudFormation, they actually define the files and directories of our projects. So I'm going to rename this to Monorepo. And we're going to be making use of the SmithyApiGateway construct, which lives in the AWS prototyping SDK OpenAPI gateway package. So whenever we update our progen RC, we need to run npx progen, and this will realize the changes that we've made to our progen RC. Okay, that's done. So we should now have a dependency on this package, which means we can declare our SmithyApiGateway project. So you'll notice here that we've got three options for the SmithyApiGateway project. There's one for TypeScript, one for Python, and one for Java. And the way in which you choose between these is you pick the language that you're writing your CDK infrastructure in. So I'm going to use TypeScript to write my infrastructure, so I'll select the TS project. So this takes a few different parameters. The default release branch is passed to most of the constructs. That's something required by progen, but doesn't really matter for our purposes. We're going to give this project a name, API, and we're also going to make sure that this project is part of the monorepo. So we're going to say parent monorepo, and we need to specify a directory for this to live in within our monorepo. So we'll add outdir packages API. And you'll notice here the client languages property. So here we can actually add languages that will generate API clients for. So we currently support TypeScript, Java, and Python. And each project will automatically synthesize its own native language client. So this one will automatically add the TypeScript client. We can add it anyway, it won't make a difference. You can also add documentation formats if you like. So we'll generate from your Smithy specification HTML documentation, plant UML, or Markdown. So for this demo, we'll leave documentation out. So this will be our API project, and we'll want to deploy our API to a CloudFormation stack. So I'm going to use just a basic AWS CDK TypeScript app to deploy our API. So let's set the version of CDK to 2. This is just the minimum version. Main for our release branch, this we'll call infra. And again, we need to make sure that it's part of the monorepo, and we'll put it in a different directory, infra. So those are our packages. So let's run progen again. Okay, that's finished now, and the final update that we're going to do to our progen RC is to add a dependency for the CDK app on our API, because we want to deploy the API CDK construct from this package in our stack. So let's declare a variable and then add the dependency. Great, and we'll run progen. And we're also going to build everything. So we can use npx nx run many target build --all all with 2 L's. And this will run the build task for every project in the monorepo, and it will manage running the builds in dependency order for you. So we'll let that complete and build and check back in a moment. Okay, so everything has built successfully. So let's see what we actually generated from this Smithy API Gateway project. So in packages, API is all of the generated code for our Smithy API Gateway TS project. Now, the best place to start is in this model directory, and this contains the Smithy model for the API. So this is the main place that you want to visit when you're editing your service. So adding or changing operations and their inputs and outputs. So this Smithy model is using the Smithy IDL or Smithy Interface Definition language. And it's a language kind of bespokely designed for building services. And Smithy and its internal predecessor at AWS are actually used as the foundation for a lot of the AWS services like DynamoDB. So it's a really well built, kind of tried and true way of defining services. So in this example, just from our default progen RC, we've been given a hello world API definition to get us started. So this defines a service called hello, and this service has one operation, the say hello operation. And this say hello operation has an input, which is a name, and has an output, which is a message. It also can throw a number of errors, in this case one error called an API error, which has an error message. We also have some traits added to our service. So the Smithy API Gateway construct will deploy the API as a REST API using JSON as the protocol. So we add this trait here. And this trait is added because Smithy is actually protocol agnostic. So we just narrow down to say this is a REST JSON API. And again, we can map our operations to HTTP methods because we're following an HTTP protocol, and Smithy is protocol agnostic. So we specify that the say hello operation is a GET request to the hello URI. Likewise, for our input for the say hello operation, we actually bind the name input to an HTTP query parameter. So that's how users should pass the name to us. So that's the model. And from the model, we have some source code generated for us. So the first bit of code of note is the API. And this is a CDK construct, which actually extends the one offered by the PDK, but it adds a type-safe interface for you to define your integrations. So you'll likely never need to actually touch this file, but rather extend it just like this sample API. So this sample API construct lets you choose how you would like to authorize requests to your service. You can pass in other options such as these cause options, which allow cross-origin resource sharing. And you must supply integrations for each operation that you promise to implement in your model. So what's quite neat is that this is actually type safe from generated types using your model. So here we have a say hello integration, and if we were to accidentally omit that, we actually get a type error because we need to provide an integration for the say hello operation, which is one of the operations we've defined in our model. So this is really powerful to just help reduce mistakes. Here we have the integration as a Lambda integration. So this means that the API gateway, when it receives a request for this operation, will forward that on to be handled by a Lambda function. Now, Lambda is the only integration currently offered by the PDK, but you can define an integration however you like by extending the integration class. So you can use this to call other services like an Elastic Load Balancer or some other HTTP endpoint if you like. Also, at the integration level, you can specify an authorizer which will actually override the default authorizer. Now, for authorizers, we support IAM or AWS Signature version 4 auth for authenticating requests. We support none if you'd like to make your API completely public. Custom if you want to use a Lambda function to authorize requests to your service, or Cognito to use identity or access tokens from a Cognito user pool to authorize requests. So we'll just leave it as the default here with IAM. Next up, so this is the CDK infrastructure that's all generated for us. So this will deploy our API using API Gateway. Here we have our function for implementing this operation. So let's have a look at the implementation of this, which was generated for us as a hello world operation. So here we have a generated handler wrapper method, which comes from our generated API code. And what this does is it provides a type-safe interface for your Lambdas to implement operations. So this gives you an input with types based on the input that you've defined in your model. So here we can see that we have an input, we have request parameters or the body. In the request parameters we have this name which matches what we expected in our input, this HTTP query parameter of name. So we have a nice type-safe interface for the input, and likewise we said in our specification that we will return a message. So if we were to omit the message, we actually get a type error here saying that the property message is missing. Likewise, we also pair these output types with the status code that we should be returning. So for example, if we returned a 400 bad request response, we're getting a type error here because we actually need to respond with an error message. And that's because our API error has an error message property here, which we promised to return. So this is really powerful for implementing your server-side code to actually implement the business logic of your API, and you can focus on that rather than having to worry about validation and whether you're returning the correct response. So that's the generated server-side handler wrappers. We also have some client-side code generated that we can use. So in here we have the TypeScript client, which was generated for us from our model. And this contains methods which lets you interact with your API in a type-safe manner. So let's just set up a bit of an example and kind of a pretend client. So here we'll just do define an async function so that we can use awaits, as we can't use awaits at the top level. And imagine for a moment that this is the customer of your API. So this could be a website which wants to integrate with your API, or another system. So we can create a client using new default API, and we can import this from our generated TypeScript client. And what this gives us is then types for our operations. So here we have a say hello method. So this is the say hello operation. And this is type safe as well, based on the inputs and outputs that are promised by the specification. So here we take a name as input, which is required. And if we get the result of that, then we also get types for our outputs as well. So the result has a message property. So this enables us to eliminate guesswork and having to worry about building raw JSON objects to send as HTTP requests, and accidentally having typos in required properties and things of that nature. So it's really helpful. So we'll just delete that for now. That's about it for the source code. Something else to note is this Smithy build folder, and that contains a build.gradle file, which you may wish to modify to add more dependencies here. So Smithy has a lot of built-in shapes and traits that you can use. There are also plenty of other AWS provided shapes and traits that you can add dependencies on here. Likewise, you might want to use third-party libraries as well. So that's where you can add them in, and they'll be included as part of the Smithy build when you run npx progen. So that's something to note as well. Whenever you update either your progen RC or your Smithy model, you should run npx progen. So let's test this out. So I'm going to go into the infrastructure now, and here is just a basic CDK stack. We're going to call it Smithy demo, and inside our CDK stack, let's add our API. So we'll import it, and it takes a scope and an ID, just like a normal CDK construct. Great, and now let's build that again. Great, that's built. So finally, let's deploy this using CDK. So we can cd into our packages infra directory and run npx cdk deploy. So I've already set up some AWS credentials for the account that I'd like to deploy into. So that's why I can just run npx CDK deploy and it knows exactly where to deploy to. And here are all of the permissions related changes. So I'll just say yes to that and I'll let this deploy and check back in once that's done. Okay, so that's all deployed now. So we have as an output the URL of our API, which we can now call. So let's copy this and we can use AWS curl. So we're using AWS curl because it automatically signs requests for us. And we can use the AWS credentials that we already have loaded into our terminal to sign the request. And we can send it to this API that had a new line at the end. So let's say call our hello operation. So the hello operation was bound in our Smithy model to the hello URI. So we can call that. And we got an error, but this is actually expected because we're missing a required parameter. So API Gateway is automatically set up with validators for your inputs, which means that you don't have to write any code yourself to make sure that your callers have provided the right input types. So we can call this one more time and actually pass a name. We said that this was a query parameter here. So we can say hello world and we get back our response. So that's just as we expect here from this say hello handler. So it responds with a message hello and then the name that you inputted. All right, so that's pretty much an overview of the full kind of end-to-end flow. Let me show you now how you would go about adding a new operation. So whenever we add a new operation, we go to our Smithy definition. So this is the model for our API. And next, let's define another operation. Let's call it post hello. So this is going to take as input a post hello input. Output can be a post hello output. And errors, let's keep it the same as well, so it can throw an API error as well. This is going to be for a post request this time. And we'll say it's on the URI hello/post this time. So a post request to the /hello/post URI. Next we need to define our post hello input. So we can copy and paste this. Let's, just for simplicity, keep the input the same. But instead we can remove this HTTP query trait. And what this will do by default in Smithy is bind the name property to the body of the request that's sent in the post request. And for our output, let's also just return a message post hello output. So we've defined our operation now, and the final thing we need to do is register it in our service. So we can add that here to the operations. Okay, so we've added our new operation. We can now go back to the root of our monorepo and run npx progen again. And we run npx progen so that all of the generated code can be regenerated from our updated model. So I'll let that run and check back in a moment. Okay, that finished. So that has generated again. Let's also rebuild. So we're rerunning the build, and actually we expect to get a build error. And if you remember from earlier, we'll get a build error because we need to define an integration for every operation in our specification. So here we've actually got an error that the property post hello is missing in our integrations in a sample API.ts. So just here we have that type error. So now we can define a post hello integration, and we'll again point it to a Lambda, and we'll create another Node.js function, and this one will be post hello. So this is using the kind of shortcut naming convention that's provided with Node.js function, and essentially if you define your handler file in a file with the same kind of prefix as the parent construct file name, dot the construct ID, then it will automatically use that as the handler file for your Lambda. So we'll add in a new sample api.posthello.ts file. And so we're going to define our Lambda handler for this. So we'll export const handler is the this time the post hello operation. So we'll use the post hello handler, which will import from our API client. And this takes in a method. And this should return the response given the request. So let's return a response which needs a status code. You can optionally provide headers in the response. We'll leave that blank. And we need to return a body. And the body needs to include a message, as we defined that in the post hello output in our model. So we'll add that in. So we'll say hello from post hello operation. We also had an input that we specified was required. So let's actually use that as well. So we can take in the input here, and the input, instead of it being a request parameter as it was before, we actually have the name in our input as part of the body. So we'll get that type here. So let's update this and say hello to our name from post hello operation. So that's our handler implemented now. So we've hooked it up to our construct here. We can now rebuild everything. Okay, that built successfully now, so we can go into packages infra and then deploy this again. And this should update our stack with the new operation that we've added. So we'll hit yes, and I'll check back in once that's deployed. Okay, that's deployed. So now we can use AWS curl again. And so this we can now use to call our new operation. So we said it was under the /hello/post path, so we'll type that. And we also said it was a post request, so we can say post as our request type, and then we can add some data that we'll send, and this data has the required field name. So name, and we'll say everyone and we'll fire that off. And so this says, hello to everyone from post hello operation. So this is our expected result from the post hello handler. Now, something quite useful as well in these handler wrappers is the ability to define interceptors. So you'll see here the type signature actually accepts multiple handler functions. So this lets you do common operations to handle requests or responses that you might want to share across multiple handlers. And an interceptor can actually choose whether or not to delegate to the remaining chain of interceptors, or finally the handler at the end of the chain. So we can define an interceptor. I'll just copy and paste one from earlier and add these imports. So try catch interceptor, we can add in as an interceptor for this operation. So what this try catch interceptor is doing is it takes in the request, and then it will wrap the remainder of the chain in a try catch. So it will try to delegate to the rest of the chain. In this case, the rest of the chain is just our handler method. It will try and return the response from that. But if there's any unexpected kind of uncaught error in here, it will actually drop into here and it will return a error response. So this is just an example for a kind of try catch, but you can write any kind of common logic that you might like in interceptors. So and interceptors that we've used in the past have been things like caching, where we might read the request, and if the request matches a certain hash, maybe it has an idempotency token, which is the same as one that we've already cached, then we can return a response from the cache instead of delegating to the rest of the chain. Other options might be logging. You could write an interceptor to log requests and responses. So it's very flexible and really easy to extend. So that pretty much concludes everything I wanted to show with the Smithy API Gateway construct. As a bit of a call to action, give this a try yourself. You can follow through the steps in this video and get a feel for it. If you have any questions, feel free to head on to the GitHub page for the AWS prototyping SDK. Feel free to report an issue on there, or if you just have a general question or a request for support, write something in the discussion board as well, and we'll try and get back to you as soon as possible. But yeah, have a play. Thanks very much for listening.